Alright guys, welcome back. In this session, we're going to continue our discussion regarding control circuits. There are some complementary points regarding them that we can talk about. If you remember from our previous sessions, we said that in a contactor, we usually have several types of, actually two types of contacts. Well, we have, for example, the power contacts, which would be these. Let me point them out. And then we said that we would have an auxiliary contact in between terminals 13 and 14, for example, like this. Okay? And we also said that when the bobbin of the contactor, talking about the A1 and A2 terminals in the contactor, starts getting this incoming voltage, like for example 230 amperes of voltage, AC voltage, all of these contacts would be closed. Talking about both of the power contacts as well as, let me point them out again, as well as the auxiliary contacts set in between 13 and 14 terminals. Now guys, in this session, we're going to see how exactly these contacts are affecting, or well, actually are being used in a control circuit. Okay, let me go to the next slide. Alright, take a look at this. As always, we have this power circuit here. And well, you know how it goes. The phase lines L1, L2, and L3 would be connected to the fuse first. And the fuse would be connected to the contactor. Contactor to the bimetal, and bimetal to the motor. To the terminals of our three-phase motor. Now, next up, as I said, we need an incoming voltage connecting to the bobbin of the contactor. Well, obviously, to the A1 and A2 terminals. Now, in addition to all of this, I've actually added this stop push button here, to this whole circuit, and don't worry, we're going to talk about it. Now, let's see what we can do here. I'm going to get a phase and connect a phase from this L1 to the fuse, like this. And then, fuse would be connected to the stop push button. And stop push button would be connected to start push button. Now, start push button would be connected to A1 terminal in the contactor. And as always, the A2 terminal and the contactor would be connected to the null. Now, if we go ahead and start pushing this start push button down, the contactor would start working. More precisely, the contacts here would start working, and as a result of all of this, the motor would obviously be turned on. Okay, and when we stop pushing this button down, obviously, again, the contactor would stop working, it would be cut off, and the motor would be turned off. Alright. Now, guys, let's say we have successfully started the motor. We have turned the motor on. The question is how we can keep it that way. In other words, how exactly we can keep the motor running. Okay, let's see how. Well, if you remember, we had a couple of terminals here called 13 and 14. We need to connect these to our start push button. Let me just draw the sketches that I had before. Okay. Now, what we should do? Well, 13 would be connected to 3 here. And 14 would be connected to 4. Now, if we go ahead and start pushing this button down, the contactor obviously starts working, but this time there's a difference. These two contacts, 13 and 14, would start working as well. Alright? And when we stop pushing it, when we pull our finger up, the electrical current will go through a path like this. It moves all the way from here, through here to the contactor, also through the contacts, and it continues following the path all the way to A1 terminal in the contactor. And as a result of this, the contactor would stay on. So we somehow made this permanent. We don't need to use our finger for pushing and pulling every time. Alright, now let's take a look at the wiring diagram or the electrical symbols that we have for such circuit. As you can see, we have the contacts here, 13 and 14. Talking about these two. And they are connected to the contacts 3 and 4 in our start push button. And somehow created an alternative path for our electrical current. And well, as I said, this would start up the contactor, this would turn on the contactor, but this time it would be permanent. Alright. By the way, guys, these types of control circuits, let me mark it out. Okay, these types of control circuits are actually one of the most important and common circuits that we can use in the entire field of electricity today.